Perfect.
Yes.
All
Yeah.
right. Great. So Alex, I'd like to start with you. In your great presentation, you basically gave us the DT vision for bringing disaggregation, virtualization, and programmatic control to a distributed cloud architecture for 5G. And you also mentioned that this is not only going to bring all of the benefits that we all know and look forward to, but this will also bring in an increased richness for the vendor ecosystem. So in a multi-vendor deployment, where there is disaggregation, there is virtualization, there is distribution across clouds and programmatic control. What are your thoughts on control and orchestration end-to-end of this multi-vendor distributed cloud architecture?
Yeah, I have to admit that it's going to be a very challenging, even if we have all the necessary open interfaces and standards already developed by multiple organizations, including ONF and ORAN and 3GPP, ETSI, you name it. Still, we are in the middle of what can I say, learning and experimenting curve. So, for example, network slicing. Let's take an example. I mean, it's conceptually it's a beautiful, and there's all the standards available there. But yes, it will take some time to ensure that all this, this end-to-end network slicing is seamlessly properly working in a multiple vendor environment. Yes, it is achievable, and also, a lot of our vendor partners have a very strong ambitions, and all together we are making a huge investment on this, what can I say, promising notions, multi-vendor end-to-end network slicing, and satisfying all these operational requirements, especially like reliability. It's not only about the performance, but more about the operational environment. And also, we need to educate or reskill, upskill our operational guys, because it's also very challenging for them, even if the vendor successfully delivered. Yeah? Your operational department has to understand how to run it, operationalize it, and how you can monetize it, and so on, so on. And also, all this back-end system, BSS, OSS, has to be, dramatically transformed in a way that you can, cost efficiently provide real-time provisioning and SLA assurance, and also proper charging mechanism put in place in your system. Not to mention the fact that you have to provide all, user-friendly portals for all your external partners. That includes developers and customers, so on. So yes, it's a very challenging, but it's exciting. And I mean, the good news is, the public, if you look at the public cloud industry, they went through this journey already. So there's already many, how can I say, technological elements available to us, which is a good news. And we have a vision, we have a target, we have a potential demand, especially initially it's the enterprise market. Yeah? So I think we have a very good momentum.
Great, thank you, Alex. John, we heard from you the progress towards the virtualized RAN. One great virtualized RAN architecture is being formed in the ORAN Alliance. And perhaps the crown jewel of that architecture is the near real-time RIC, where basically we are disaggregating some of the control functionalities from the individual disaggregated components. So turning the RAN control into a programmable paradigm, what challenges would that bring to the design of the hardware and the software components for the RAN?
Yeah, that's a great question, Oz. When we look at the opportunity for basically bringing enhanced processing, so you mentioned, where the near real time, RIC is being performed versus relative to the non-real time. And so as we're kind of pushing into some of these optimized interfaces, the challenges in some sense relate to where the processing is and where the latency is adding up. And so when we look at the opportunity for having, say, even as Alex was mentioning, you're trying to have some SLA or some end-to-end performance, say for an industrial enterprise application, then how you partition the processing. On one hand, absolutely, we want to leverage the open interfaces, in some sense, have a network APIs where we're able to have end-to-end optimization that's use case specific. So on one hand, we want to have flexibility such that we can support a large number of different services, as I mentioned in the factory environment, but then at the same time, have leverageable hardware where we can take the same hardware solution and with appropriate disaggregation, serve these multiple use cases that have different needs. And so as we get into the specifics of, say, particular implementations that are driving higher reliability, that's where we see this aspect of, what's occurring in a virtual distributed unit. And then how are we partitioning the processing? When are we leveraging, in terms of the different baseband architectures, the role of GPUs, the role of more traditional baseband architectures to achieve, in some sense, sophisticated signal processing, but doing it in a way where the latency is as important as the MIPS, right? So we're looking at the operational requirements in terms of the overall compute, but at the same time, understanding that the latency needs of these specific use cases, we have to ensure that as we're doing this near real-time optimization, that we're not adding additional latencies that are going to basically break the overall goal of the QoS for that use case. So it's absolutely kind of an end-to-end optimization. And so the divide and conquer approach works well. At the same time, we have to pay particular attention to all of these interfaces such that we don't have an accumulation of latencies that in the end, start working against the target goal for that use case.
Great, thank you. Larry, so John just mentioned that in addition to CPU, we could leverage GPU for some of the RAN functionality. And in your talk, you also gave us a good synopsis of how we could leverage the switching silicon as a programmable entity towards realizing the user planes of 5G, both potentially for the RAN and for the UPF of the core. So that effectively means that we're talking about edge clouds in the telco sense with hybrid hardware. And yet, we're talking about virtualized workloads. How would that impact that hybrid hardware architecture into our capability for developing CI/CD solutions, DevOps models, and in general, automation and operationalization of such an edge cloud?
Yeah, great question. In fact, it connects the dots between your question to Alex and to John, because adding all this extra stuff, the GPUs, the FPGAs, and so on the one hand, you could think of it as complicating the orchestration and management problem. And I think the key thing here is that we need to not make the problem harder. It's already a hard problem. We need to not make it harder than it already is. And the way you do that is you try to avoid treating things as different. You like them all to be cattle and not pets. And so I think we have to think about there being, at some level, I'm managing commodity hardware with various characteristics and software running on that hardware. And I need to do the best job I can is to make everything look as much alike as possible so that my tried and true cloud practices can be applied and I don't have to go off and reinvent something different. So just give you a little tiny example here. It's already the case that I was showing you. There was a server and a switch. You treat those as different things, and now you've added complexity. You siloed them and you've added complexity. But if you think of they're just both compute engines. One is really, really good at forwarding packets from input port to output port, and the other is really good at running for loops. But they're just processors. And if I can treat them in the same way and manage their software in the same way, then I've simplified the problem. So for example, on the switches that we have in kind of the example I was showing, we run Kubernetes on the switch in the same way we run Kubernetes on the server. And the special software running on that switch is a microservice. It's running in a Docker container. And so we load, so that elevates up to the management level. Everything is a computer and all the software microservices running in containers. And then we get to leverage a common orchestration machinery of, in this case, Kubernetes. So I think that was kind of the message I was trying, and it's a difficult one to wrap your head around. The more that I can treat things as alike and reduce problems to common problems that I have solutions to, the better off I'm going to be. Now, the counterweight is that, well, my thing is special, but we need to treat it, we need to avoid that trap.
Excellent insight. So let's move into maybe enterprises next. Alex, you mentioned in your talk that one of the POCs that you had was towards enterprises. So in general, for a private 5G network, what is your or the DT vision? Where do you think enterprises would utilize 5G, and how would an operator like DT enable that?
Mm-hmm. Yeah. Before I get to that, let me just add some comments on what you asked before, regarding the cross-domain orchestration and so on. So one of the, how can I say, our architecture principle we adopted within the Deutsche Telekom, my organization, is orchestration should be based on model-driven, data-driven, so on and so on. Yeah? And also we have to change our approaches from fully, how can I say, legacy standard driven to much more leaner and leaner approaches, because the existing standard with around this NFV, or this network function virtualization, it seems quite heavy. Yeah? So that's a big burden. So for telcos to be able to properly integrate into our systems, and it's very costly. So we started to look for more leaner approaches, and cloud native is one of the key elements there. And all this, netconfig, YANG, and all those emerging tool chains, including CI/CD and the data analytics, they're all going to be incorporated in our approaches, so that we can unburden our all this orchestration development, especially the cross-domain orchestration. So I think we are in the right track at the moment. And back to your questions, enterprise. Fortunately, in Germany, the country I'm living now, there's a many good demand here. Vertical market, automobile industry, logistics, and we have many big enterprise here. So they are approaching us, and so we have a lot of joint projects, starting with the POC, and then trials, and then we are looking forward to the final, more like a real use cases, business cases, deployed in their factory or campus and so on, or even on the road. And there is a big discussion between about that, okay, what connectivity solution would be best to fit, yeah, for the campus network between the cellular and cellular 4G or cellular or 5G, standalone, non-standalone, private, public, or hybrid, and even Wi-Fi 6 is a strong challenger candidate. So it depends, depending on the use cases, completely depending on the use cases. Some use cases, cellular technology gives the best fit, whereas some use cases, probably you can use the Wi-Fi, Wi-Fi 6, nothing's wrong. It's very good technology and very cost efficient. And the licensed spectrum versus unlicensed spectrum, or in Germany, government allocates private spectrum, 3.x midband for the industrial stakeholders, which is a very unique situation here. So then they don't need to pay too much about the usage of the licensed spectrum, which is very, very, industry-friendly movement. So overall, we are quite busy collaborating with some of the leading, what can I say, technology companies like Siemens, Bosch, and also we are working with many automobile company, BMW and Daimler. So we are in good shape. And the standalone of the issue will be still, if you are talking about the use cases on the shop floor, like a production line, then there will be additional requirements, especially the time synchronization and so on. And the reliability, will be quite stringent, reliability requirements. So you need to deal with all these additional requirements, and this 5G core is ready, it's available for the B2C market, but for the vertical market, you still need to do something, to adapt to this campus network, because you don't need a big scale, packet core like an EPC or cloud native or 5G core. Rather, you want to have it in a smaller scale. Therefore, you have to be able to downscale your packet core, and even you can introduce some edge cloud together with next to your packet core for the on-prem use case in the vertical, or you can completely leverage all your public infrastructure, public network, making sure that you allocate some dedicated resources for certain enterprise use cases. So the opportunity space is much, much bigger, broader. That's good news. But then because of the variety of these use cases in the enterprise, you need more resources, right, to provide sufficient technical support and even the consulting. So there is opportunity, there are the challenges, but overall it looks good.
Thank you, Alex. So John, maybe following on a similar question about private networks, and you also mentioned with release 16, we are talking about an NRU. So especially in the US, that means bringing CBRS into the picture. And Alex also mentioned that, depending on the enterprises, there is going to be demand for 5G and sometimes 4G, but also Wi-Fi. And as Qualcomm, you are a prominent player on both ends, both the mobile space and the Wi-Fi space. Do you envision maybe an integrated solution towards enterprises where, under a unified platform, if you will, an enterprise can leverage both?
Yeah, that's a great question, Oz, because it is something where, as Alex mentioned, there's certain countries where, as we look at enterprise, there's dedicated spectrum like the 3.7 gigahertz band in Germany, where Qualcomm has been also working with the companies like Bosch and Siemens, and obviously also many discussions with DT themselves. And it's something where we always look at the public network relative to the private network, and even this hybrid opportunity. And so there's the device side aspect of, say, roaming. If you're doing a logistics solution, say for a container port or something where there's all the trucking industries involved, and there's something where the sheer amount of traffic being generated in that area justifies a private network. And at the same time, when those things move on, they're handing off into the public network. And so similar, when we look at these hybrid approaches, then the aspect of Wi-Fi for enterprise, obviously it continues to be incredibly important for companies like Qualcomm, as you mentioned. And at the same time, when we look at the 5G private network opportunity, it's something that brings in some of that that kind of end-to-end opportunity for ultra reliable, low latency communication, and kind of bringing in some of the stuff that was part of Release 16, whether it's time-sensitive networking and kind of working in conjunction with unlicensed spectrum. But I think to your question, that absolutely it is possible that on the network side, and as we look at the opportunity to have both Wi-Fi and, say, a 5G private network, and we look at even the deployments for, say, a 5G millimeter wave system, is very similar to the Wi-Fi access points that already exist today. So when we look at the evolution of say, if it's a hospital of the future, or we look at the use case of a factory of the future, a school of the future, or someone even working on new premises for work or for home, there's this opportunity to look, as you say, holistically at, okay, what are the communication requirements and what are the range of services we're going to offer? And I think, as Larry was saying, we don't want to end up with like 17 different networks for 17 slightly different scenarios. And so the challenge of reuse and global addressability. And so it is something where obviously the role of Wi-Fi is going to continue to be very important. And so then the ability to have the evolution of 5G and Wi-Fi, and then this ability to serve a wider mix of device classes, some of which are going to leverage NR, 5G NR and unlicensed spectrum, and some of which can leverage a Wi-Fi solution. And so that, in some sense, that kind of unification, if we're looking at the use cases, we're looking at the requirements, we're looking at the deployment realities, and then so how do we bring the benefits of, say, the 5G end-to-end security or the provisioning, the fact that then it can be something that's locally managed, it can be a much lower cost, 5G private network. I think, some very good points from Alex on kind of a thin core implementation where we look at the functionality that's required for, citywide, wide scale, cellular network system versus a more locally optimized, 5G private network, then you can have a much thinner core solution. And so it's something we look at the overall opportunity on the network side, the different pieces that come together. And then we look, obviously, from the device side as well, what are the range of services that exist today? And as we're looking at the evolution of those services, what we always want to ensure is forward compatible investment. So whether it's an enterprise or even an MNO making investments into their network, the question is, what investments are they going to make in 2020 that in 2025 they're going to look back and say, wow, that was a really wise investment because I'm able to scale and add functionality, leverage the evolution of the services, but do it in the most cost-effective way. And so, doubling back to the question on the opportunity for 5G and Wi-Fi and devices, obviously, that have both, and networks that have both, I do agree that that's a very important part of the ecosystem. And it's also something that we have to keep in mind that the 5G system itself is evolving to such an interesting cost structure of some of these deployments. And so the sheer momentum of disaggregated RAN and virtualization, and we're looking at these small cell type solutions of virtualizing RAN, then all of a sudden we have this kind of complete modem to RF solution, and the ability then to deploy that at scale at cost structures that obviously are very competitive with Wi-Fi. So you have this interesting part. You're not bringing together two disparate systems. It's rather also the fact that the 5G system itself is able to scale to much higher density and decrease cost structure, and at the same time bring in some of these end-to-end benefits.
Thank you, John. So I'm looking at the clock, and I think we're already a few minutes over. So with that, Alex, John, Larry, I thank you all for your presentation and for answering all of my questions so patiently. And with that, I turn it back to you, Denise.